Welcome back. I see people slowly starting to trickle in. So just a reminder, if you haven't registered, it's out in the lobby. Don't feel like you have to go now. You can go after, whatever. But do ask that you do that at some point today before lunch would be good. Otherwise, we're really excited for another day. First up, we have here Mr. Robert Cabana, the director of the Kennedy Space Center. So turn it over.
Thanks, Andrew. Oh, good morning. I'm going to tell you what's going on at the Kennedy Space Center and what the future of spaceflight is for NASA today. The Kennedy Space Center itself, for those that aren't all that familiar, it's a 144,000-acre wildlife reserve, and it is a pretty awesome place. Our budget's about $2.1 billion a year. Most of that is program funding. It goes to fund the three major programs we have at KSC. And we spend about $330 million a year just running the center. We obviously have some challenges in front of us, not just KSC, but NASA as a whole as we move forward, given a flat budget for the next 5 years and what that means. But bottom line is, we got the money to do the right thing as we move forward, and we'll talk a little bit about that. That's everybody has a vision and a mission statement. If I could summarize it, you know, KSC is America's spaceport. We want to make KSC a multi-user spaceport of the future for both government and commercial operations, crew and cargo, to and from low Earth orbit and beyond, as well as suborbital flights. And we'll talk a little bit more about that. I put this up here for perspective, all right? That was a little over 100 years ago, December 17, 1903. Orville and Wilbur made the first flight in a powered aircraft. It lasted about 20 seconds and traveled 120 feet. 120 feet is the length of the Space Shuttle orbiter. And, you know, aviation, a little over 100 years ago, was that. Look at what aviation is today, all right? This is our Wright Flyer. That's May of 1961. Alan Shepard flew on a Mercury Redstone, went up and did a parabolic arc, spent about 50 days and came back down, and that was the flight. The amazing thing about that is, that was May of '61. 8 years later, we were on the moon. How did we do that in just 8 years? And you look at how long it takes to do things today. Part of the issue is the budget. At that point in time, during the Apollo program, NASA had 4.5% of the federal budget. Today, we have less than 0.5%, okay? 10 times as much money. Think what we could do with $178 billion instead of 17.8. But again, given the fiscal environment that we're in today and the deficit that we have, it's not going to happen. So we have to figure out how to be the most efficient we can with the funding that we have to ensure that we have the right future going forward. That's an historic picture also. That's April 12th, 1981, the maiden voyage of the Space Shuttle Columbia. And to me, this was the ultimate test flight, all right? Flying with humans for the very first time on an orbital space plane. And it was piloted by a couple of my heroes, two Navy test pilots, John Young and Bob Crippen. And that was a tremendously successful mission. We learned a lot as we move forward. The Space Shuttle itself, and you know, it's history, but I like history. And just to give you a little tour for those of you that are interested. You got the commander that sits over here and the pilot that sits over here. And the commander is really the pilot in command, and the pilot's the co-pilot. But pilots don't like being called co-pilots, so they call him the commander and the pilot. Now, the pilot, his probably most important job, right here, there's two switches. This one arms the gear, and that one lowers the gear. And so I was the pilot of Discovery twice, and I got the landing gear down. If you don't lower the landing gear, that's probably career limiting. You're probably not going to get to command a mission. So I got the landing gear down twice, so they let me command Columbia. And that was pretty cool. When you actually get to land the space shuttle for the first time, you know, here's this $3 billion spaceship, 200,000-pound glider falling out of the sky, and you got one chance to make it right. But I got to tell you, the first time I did it, I felt like I'd done it 1,000 times before. And I had in the shuttle training aircraft, which is a phenomenal simulator. That's a whole other talk. I'm not going to go through that talk. So the shuttle, the commander's got the environmental control system, the main computers, just to put things in perspective, where we've come since we built the shuttle back in the 70s. The shuttle has 5 general purpose computers. That's where you power them up. You interface with the computers through the 3 displays here and the keyboards here. When we first built the shuttle, it's the AP101B computer. It was the same computer that was in the B-1B bomber, a rad-hardened computer, very reliable, worked well. 104K of memory, all right? And then in the 90s, we upgraded it to 256K of memory. Those computers were built by IBM down in Owego, New York. Excellent. In fact, in the original part of the mission, when we were flying the shuttle, we actually loaded, you have to load software for different phases of the mission because the memory wasn't big enough to hold it all. So when you got on orbit, you loaded from mass memory tapes for your on-orbit software, and then again for your entry software to come home. Eventually we got to digital mass memory units. I mean, we used to fly these tapes from Houston to Florida to load into the shuttle. Then we started transmitting electronically. Eventually went to digital mass memory units. But the basic computer itself, when we quit flying the shuttle, was still that 256K memory computer. The maneuvering the orbiter on orbit, reaction control system aft and forward, and the orbital maneuvering system engines. As you know, propulsion in space, you want something very reliable. And we use monomethyl hydrazine as the fuel and nitrogen tetroxide as the oxidizer, MMH and N2O4. They come together in a hypergolic reaction. They explode on contact. No ignition system required. Not very environmentally friendly, difficult to process on the ground. We're looking at methane systems for on-orbit maneuverability. But the nice thing about hypergols is they're very stable on orbit when it's kept separate. And no ignition system, no spark plugs required. Very reliable, simple system. Just use inert gas, helium, to pressurize the propellants down to 2 ball valves. When the ball valves are open, the bipropellants come together in the pressure chamber. As long as the ball valves are open, you're getting thrust. And then over on the pilot side, man, there's a lot of switches over on his side that any one of them thrown at the wrong time, really bad things can happen. Hoot Gibson, when he was commander and also chief of the astronaut office, one of his laws was no emergency is so bad that the pilot can't make it worse. And that's very true. But you got the electrical control system, 3 fuel cells, develop about 7.5 kilowatts of power each. You got the auxiliary power units that power up the hydraulic system, triply redundant 3,000 psi hydraulics for the flight controls, main engine gimbalings, and then all the main engine controls are over there. The shuttle utilized 3 liquid-fueled engines. The SME is the most fuel-efficient liquid rocket engine in existence, and we're still going to use those. I'll talk a little bit more about that. So that's kind of a quick tour of the space shuttle. You can operate the space shuttle from the front cockpit on orbit, and when we do rendezvous and prox ops, we're flying it from the aft station. I want to talk a little bit about the space station, and you're going to hear more about this from Peggy Whitson later. But this is rendezvousing with the Russian functional cargo block. You can see the first U.S. module attached to the docking station on the orbiter. This is the Unity node and the FGB. Eventually, they came together, and that was the beginning of the space station program in '98. But in October of 2000, we launched the very first crew to the space station on the Soyuz rocket. Bill Shepard, Yuri Zinko, and Sergei Krikalev. And ever since then, we have had a permanent human presence aboard the space station. We dropped down to a crew of 3 sometimes. After Columbia, we had a little bit harder time maintaining the space station. Eventually, we came back after Columbia, we completed the space station, and now we keep a crew of 6 up there. That's the space station today, and I'm sure Peggy will talk more about it, but it is an amazing engineering technical accomplishment. That's Don Kettit in the U.S. laboratory, and just to maintain the space station as big as it is, we need 3 astronauts just to keep up with the daily maintenance on it. And then if you really want to do some science, and that's what we want to do now. We've built this phenomenal microgravity laboratory in space, let's utilize it. And we'll talk a little bit more about that too. The Space Shuttle program, phenomenal 30-year program. It gave us a space station, the Hubble Space Telescope, probes to numerous planets. It also allowed us to work with the Russians. We docked with the Mir space station, utilizing the shuttle. And the Shuttle Mir program, had we not done that, we wouldn't have been able to do the space station program with our Russian partners. We learned a lot working with them. They learned a lot about us. And it laid the groundwork for the International Space Station agreements that we have. We've come a long way since then. But the end of an era, but it's time to move forward. A little bit about the space shuttles. You can see them being transferred there. I think it's kind of neat where each one of the space shuttles ended up with. I know there was a lot of discussion about why wasn't one here or why wasn't one there, but it turned out pretty good. We got Enterprise up in New York, Discovery at the Air and Space Museum. It looks like it landed and just rolled into the hangar. Discovery is the actual vehicle of record for the Smithsonian. We're utilizing all the main propulsion components out of the space shuttle for the Space Launch System. The shuttle main engines are going to be part of that. I'll talk more about that. So we've got all the engines removed and they're in storage. In fact, I was up at the Stennis Space Center a couple of weeks ago, and they're at the Rocketdyne facility up there at Stennis in storage, environmentally controlled, and we're going to utilize those on the Space Launch System. All the main propulsion valves are going to be used also. So on Discovery, when we pulled those valves out, we replaced those valves with non-flight valves that had either been through the end of their service life or whatever that we still had. So if you look in the aft compartment of Discovery, all the plumbing's back there, all the valves are there, everything's there. If you go onto the flight deck of Discovery, everything's there. If you go onto the mid-deck, it's got the waste control system, the galley, all the lockers, all the seats, everything are installed. It really does look just like it landed. Endeavour and Atlantis, a little bit different. When we pulled the stuff out of them, we didn't put non-flight stuff back in. So they weigh a lot less. A normal orbiter coming back from a mission weighed about 195,000 to 200,000 pounds. Atlantis right now weighs, I think, 157,000 pounds or something like that. We pulled a lot out of it, but it's still looking good. Now Endeavour, out at California Science Center, is going to be mounted in the vertical on an external tank and solid rocket motors, and they're going to build what looks like a launch structure alongside it so you can climb up and look at everything. So you got Discovery looks like it just landed. Endeavour looks like it's going to be taken off. And this is what we're building for Atlantis at the Kennedy Space Center. Last Friday, we rolled it into its new facility. They're in the process of attaching the necessary brackets and everything to jack it up, and eventually it's going to be mounted at about a 45-degree angle with the payload bay doors open, and it's going to look like it's in space. And I tell you, there's a lot that's going into making that happen. But it's going to be a beautiful facility when it's complete, and it's going to tell that 30-year story of the Space Shuttle program, what we accomplished, as well as the space station in there. Down at the Kennedy Space Center, we have 3 major programs, and that's new for KSC. The Launch Services program came to Kennedy back in '98, and that was the only program that we had. For shuttle and space station, the program management was at the Johnson Space Center, and we just had projects at the other space center, but all the funding flowed through JSC. We now have the Ground Systems Development and Operations Program that's preparing KSC launch support not only the heavy lift rocket, but also commercial operations from the Cape, and our Commercial Crew Program that is providing us a capability to get our crews to the International Space Station on a commercial rocket. Ground Systems Launch Complex 39 is where the major investment is being made to transition to the future. If you look at the pads at KSC, you got 39A and B, and 39B, the northernmost pad, we've removed all that shuttle infrastructure that's still out there on 39A. It's got a state-of-the-art lightning protection system. We pulled all the copper wire out the pad. In fact, we made $630,000 in scrap out of the copper that we reinvested back into the project. It's all fiber optics now, digital control systems. That pad looks like just a mound of dirt and cement, but it's a huge complex underneath there. So digital control systems, refurbished propellant distribution system, it's ready to support the future. If you look at the mobile launcher here, that was originally built for Ares 1 in the Constellation program that was canceled. It is just structural steel. It was never completed. Only the structural steel was completed. We're going to take that mobile launcher, and the mobile launcher has a common interface to the pad. So you could have multiple mobile launchers with different rockets and a common interface to the pad and not have to design the pad uniquely for a specific rocket. Now, the Ares 1, it only has one big hole in the middle of that platform, so we're going to have to modify it to support the Space Launch System to allow for boosters also. And then we're going out with contracts to install the systems in the structure itself to support that heavy lift rocket. Vehicle assembly building, I'll talk a little bit more about that. We're modifying High Bay 3 to support the heavy lift rocket. High Bay 1 is available for commercial operations should that work out. The Launch Control Center has 4 firing rooms. Firing Room 1 has been totally remodeled to support the future. It's configurable for any way we want to do it. Requires fewer people to support the launch pad. And we're going through software testing right now to control Launch Pad 39B from the firing control room, make sure all those systems that we've installed, everything works the way it's supposed to. All right, if I can get whoever is driving the computer, I just want to show you what's going on in 39, or in the High Bay 3 here quickly. They told me we're pulling out the platforms from the Space Shuttle, and you expect a platform to be just a platform, but these things are the size of small 3- and 4-story buildings. You get some perspective on the size of these platforms that we're taking out of there and demolishing. Just as we transition the vehicle assembly building from Apollo to the shuttle, we're now in the process of transforming it from the shuttle to this future heavy lift rocket. So for NASA, exploration, that's where we're focusing on the NASA part of this. Commercial crew to low Earth orbit, exploration beyond our home planet, the Space Launch System, and the Orion crew vehicle. The Orion crew vehicle, right now, we've, in partnership with the state of Florida invested $35 million in the operations and checkout building High Bay, where the Apollo spacecraft were processed, the mating of the command module and service module. And we are actually building, that's a production facility now, and we are building the Orion multi-purpose crew vehicle, Lockheed Martin is, within that High Bay. And this is a state-of-the-art facility. It's absolutely awesome. And the first flight vehicle is there right now, and that's scheduled to fly in 2014. It's going to launch on a Delta IV rocket, and it's going to take it out a little beyond 30,000 nautical miles. And then it will re-enter at near lunar re-entry velocities to check out the thermal protection system and the other systems on the vehicle. We were just going through pressure testing of the vehicle here this last week. So, 2014, that's not very far away, and that's the first flight of the Orion spacecraft. The rocket itself, we're looking to fly the Space Launch System in 2017. This is the mobile launcher that we're modifying. The rocket itself is evolvable. We have gone to a sustainable, evolvable design, starting out at 70 to 90 metric tons, eventually evolving to 130 metric tons, which is what we feel we need for a Martian mission. Now that's further down the road. What we want to develop is a capability. It's not destination specific, but it's able to go to asteroids, the moon, Mars, Lagrange points, and it's evolvable and sustainable. The design that we settled on uses a 27-foot diameter core. Apollo was 33 feet. 27 feet is the diameter of the shuttle's external tank. We're utilizing 4 shuttle main engines, liquid hydrogen, liquid oxygen engines, and initially we're going to use up the shuttle engines that we have. We have 15 of those in storage, so that with one more that gets us the first 4 flights. And then it's no longer called the Space Shuttle Main Engine anymore, SSME, it's the RS-25. And we're going to an expendable version of that engine. Essentially the same, but it won't have to be as reliable for multiple starts. It only has to start, at the test at Stennis and one time down at the Cape. So there are cost savings that can be made as we develop and build that engine. And then initially we're using solid rocket motors for the boosters, but instead of 4-segment, they're 5-segment boosters to get more thrust. And we've got studies out now to look at an advanced booster system, either solid or liquid propulsion, and we'll see how that all works out. But the first flight of this rocket is scheduled for 2017, and all the modifications that we're making at the Cape are going to support that. I promised the Bill Gerstenmaier and the folks in HEO that KSC would not be the reason that we don't launch on time. We're going to deliver a quality product on time, within budget and within schedule. The Launch Services Program, as I said, has been at KSC since '98. This happens to be the Mars Science Lab on top of an Atlas rocket, well, not quite on top, getting ready to encapsulate. And as you know, it launched a year ago, last November. How many stayed up and watched that landing on Mars? Wasn't that phenomenal? I'm thinking, I got invited to go out to JPL for the landing, and I thought, hey, what's the big deal? I mean, it's pretty cool, this big thing's going to Mars, but I mean, all these guys on console getting data, it's not like when I was on console and mission control where you can actually make inputs and change things and do things real time to impact what's happening. They're just making sure and reading back that everything was going as it was supposed to and was pre-programmed. Man, it was the most exciting thing I've done in ages. It was so cool watching that data come in and being there with the engineers. And then, getting the pictures back and when it landed and stuff. That is absolutely phenomenal. And I'll never forget the first time I saw that video of this thing and how it was supposed to all work, the cartoon. I said, you think you could have designed a more complicated way to get this done? But it all worked. That's NASA, man. It's awesome. It's just really cool. And I really believe, we have the most talented, dedicated workforce anywhere. If you tell them what you want done, point them in the right direction, and give them the tools to get it done, the resources to make it happen, and then get out of their way, they can do it. And we're looking for more of you guys to come and be part of our team. This is our launch schedule manifest from the Launch Services Program for the next couple of years. The ones in yellow launch from the Cape. The ones in white are out from the West Coast at Vandenberg Air Force Base. Not quite as many science missions as we've launched in the past, and then it picks up again a couple of years after this. But the Launch Services Program is key to NASA and what we do. It's part of our exploration program. The robotics missions that we send out, they're precursors to having humans go back to the moon, to go to Mars. What we learn through our robotic spacecraft is critical as a predecessor to human exploration. This is how we're getting our crews to the International Space Station right now. We're paying the Russians, okay? We do not have currently a U.S. capability to fly our own crews to our own space stations, and we're going to change that. And we have the Commercial Crew Program resident at the Kennedy Space Center. But truly, it's a partnership with the Johnson Space Center. The program manager is at KSC, the deputy program manager is at the Johnson Space Center, and the resources are split pretty much 50-50 to make this happen. Obviously, operations at Cape focus on the vehicle. Operations in Houston focus on the crew and the operations going to and from the space station. Vehicle design is involved in both places, but a lot of what we're doing with Commercial Crew, we're applying some of the stuff that we've learned with the Launch Services Program and how we procure our science missions for NASA. Right now, we've narrowed it down to 3 competitors through Space Act agreements to get to eventually a contract to fly our crews to the space station, hopefully in 2017. The 3 are Boeing with the CST-100 spacecraft launching on an Atlas V rocket, Sierra Nevada with their Dream Chaser based on NASA's HL-20 design, also on an Atlas rocket, and of course SpaceX with the Dragon capsule on the Falcon 9 rocket to get up there to the space station. Boeing is making great progress. They know how to do this. The Dream Chaser is a little further behind, but it's a different design. A lifting body is much more complex than a capsule as far as re-entry is concerned. SpaceX, of course, you've seen them deliver commercial cargo to the space station now, and they want to evolve that Dragon capsule into the Dragon Rider, a crew-rated vehicle to fly crews. And we're making great progress on all three fronts there as they meet the milestones that they need, and then we're working on another contract to help them define the requirements for human rating their vehicles, eventually getting to a point where we can award a contract to actually fly our crews to the space station. CASIS, the Center for the Advancement of Science and Space, is a nonprofit resident at the Kennedy Space Center that is going to actually bring commercial science to the space station and help utilize it for what it was meant for. They've signed their first agreement, and I'll let you ask Peggy all the tough questions about science in space. She's a renowned biological researcher as well as a really awesome astronaut, having spent a year up there. Partnerships are going to be the key to the future for the Kennedy Space Center as we move forward. The launch complex itself is a huge expense, and if we're only launching once a year or once every other year, we want to make sure that we're utilizing our facilities, our talent, our engineering expertise in the best possible way, and that's through partnerships, commercial and with other government agencies. At the peak of Apollo, there were 25,000 contractors and civil servants working at the Cape. But remember, that was back when we had 4.5% of the national budget. At the peak of Shuttle, it was about 18,000, but we averaged out the last 3 years at about 15,000. In the last year, we've laid off about 7,500 people at the Kennedy Space Center. We're down to 8,500 folks working there right now. All right? But what we're doing is, instead of being dependent on these huge government programs, Apollo, Shuttle, Space Station, we're pulling folks back in to a strong engineering core, our engineering department, a strong safety and mission assurance program, and we're providing core resources to multiple programs, commercial and government. And in the next couple of years, we'll build back up to probably around 10,000 folks working at the Cape. And we don't need as many as we did in the past because we're going to be more efficient, more cost effective, and the vehicles do not require the touch labor that the shuttle required. Okay, we're going to have better designs that are more efficient in how we process them as we move forward. But my Center Planning and Development Office, they're the front door to the Cape for working these commercial agreements. If I could say the one thing that has challenged me the most in this last year running the Kennedy Space Center, it's trying to get these agreements in place. It's a new way of doing business. It's new for NASA. It's new for a lot of folks. And it's been a real challenge as we meet all the federal requirements and the restrictions that we have. And the question that I've finally started to ask is, as we do these things, is it statutory? Is it a law? Is it something that absolutely, you have to follow it? Or is it just a best practice or a guideline or one of our own requirements that we can change? And unless it's statutory, if it's just a requirement that we can change, or we're looking at doing it more efficiently and getting these things done faster. Probably one of the neatest commercial agreements we got, as I said, we've got a lot of excess capacity with the shuttle being gone. I've got 3 orbiter processing facilities that I have no use for the Space Launch System for our future exploration program. So can we find commercial companies to come in, utilize that space? I've got a building, I can't afford to maintain it, and I can't afford to tear it down. It's a good building. Can I get somebody else to come in and work there? And the state of Florida, through Space Florida, has taken over the maintenance and operations of OPK-3, and they've signed an agreement with Boeing to come there and build and operate their CST-100 spacecraft. And we're about this close to having another agreement for OPF Bays 1 and 2. So we're continuing to move forward as we broaden our base and make efficient use of the critical resources that we have. This is Exploration Park. This is the Space Life Sciences Lab that the state of Florida built back in 2004. We've moved it outside the fence, And we've leased this land to Space Florida, and they are going to build, with this being the anchor tenant, the Space Life Sciences Lab, this industrial research park adjacent to the Kennedy Space Center on government property, but it will be, bringing in both research and engineering, actually building hardware as the facilities move forward. And they're looking at starting construction of the first building in that site early next year. So what does KSC look like for the next 10 years? Our mission is going to be, supporting our exploration program with the Space Launch System and the Orion Multi-Purpose Crew Vehicle. It's going to be commercial operations to low Earth orbit, and it's going to be our launch services program, providing those expendable rockets to take us, our science missions, where they need to go. We're also looking at bringing in, utilizing the shuttle landing facility, suborbital flights, X-Core, maybe Virgin Galactic one day. And I look at, those suborbital flights, you say, well, is that really going to space? What benefit is there from something like that? But if you look at where we are in commercial space and where aviation was after World War I, going up on a parabolic flight and getting into space, just to be there to experience it. It's not unlike when you went to the county fair and you jumped in a Jenny, a biplane, and you went up and you got 2,000 feet over the family farm, and you got to see it for a little bit, riding in the back of a biplane. That stimulated an interest in aviation. All right, it evolved from there. The government was involved with U.S. Mail in aviation, stimulating that industry. All right, we are involved in commercial crew. We're stimulating that industry, giving them a reason to go out and procure these vehicles that we can contract with, and they can be used for other folks to get to low Earth orbit also. And I think those suborbital flights are just as important. So we're looking at what can we bring in to the Kennedy Space Center that supports this multi-user spaceport of the future. And then eventually in the next 25 to 30 years, and there's a quote from our administrator, and I think it's a great one. All right, you guys probably can't read all that from down there, so I'll come over and read it to you. But this is Charlie Bolden earlier this year. Our destinations for humans beyond Earth remain ambitious. They include the moon, asteroids, and Mars. The debate is not if we will explore, but how we will do it. And we're going to do that. That is our future. It's our destiny to explore beyond our home planet. And we're making that happen. And that's where NASA really needs to focus. We've been going back and forth to low Earth orbit for 50 years. We know how to do that. It's time to transition orbital operations to the commercial sector and allow NASA to focus on the really hard job of exploring beyond our home planet. What I'd like to do is, I got time here now. I would love to take questions from all of you on anything and everything that's going on at KSC, at NASA, and where we're going for the future. So who wants to jump up and be first this early in the morning and is awake out there? Yes, sir. And we got a mic so everybody can hear.
Hello, sir. Good morning. Thanks for the info. It was great. I hope we never get used to tragedies like Columbia and Challenger. They're obviously not where we want to be. But do you feel that the fallout fiscally and the fallout in terms of NASA support from the country after Columbia was continued fallout from the failures that led to Challenger? And in light of that, were the failures still in place? And if, regardless of whether the failures were in place, how do you convince taxpayers outside of Florida that our ambitious goals of reaching Mars and beyond are worth the effort?
Well, first off, nothing worth doing is easy, all right? And space is a very harsh environment. And we are going to continue to have issues as we move forward. And I truly believe the true measure of a person is not the mistakes they make, but how you recover after those mistakes. And just because something doesn't go right doesn't mean that you quit and give up. and that's not who we are as a nation. We rise to the challenge, and we do better. What caused the Challenger accident was different than what caused the Columbia accident. Were there NASA management policies that may have added to the two? You can argue however you want. The bottom line is the people that made decisions on both of those missions, they weren't taking shortcuts or making decisions that they thought was going to put the crew's life in jeopardy. They thought they were making the right decisions based on the data that they had. Maybe they needed more data, but as a management, from a cultural point of view, I think we changed significantly after the Columbia accident, and we learned things that we had accepted. We realized we could no longer accept. And when we flew Atlantis, the very last shuttle mission, it was probably the best processed shuttle flight we have ever flown. It had the very least amount of damage when it came home, because we learned how to deal with the foam on the tank and how to protect and have plans in place. Did that impact the support NASA had? I don't think that it impacted it at all. I think the American public expects us to explore. In fact, that's part of the problem. They think we've done a lot more than we have. And it's probably our fault for not communicating better, why we do what we do, and the necessity to continue to do it and move forward and explore, and how it impacts our economy, our lifestyle, and our future. So we need to do a better job communicating with the American public and sharing what we've learned, showing the importance of it, and why we have to continue to move forward. Another question, way in the back.
Yes, with regards to the Space Launch System, you've repeated several times that it's sustainable. I'm curious how you define the sustainability of the Space Launch System.
Okay, I say it's sustainable because, first off, we've chosen a design that is the most cost-effective for what we're doing, utilizing technology that we know, utilizing resources that we already have. From a cost point of view, it's sustainable in that we can live within the budget that we have. Is it reusable? The Orion vehicle is reusable. The rocket itself, no. In fact, the solid rocket motors, we're throwing them away. And there are advantages to that. First off, we have a ton of casings on the initial flights that we can just use up, left over from the shuttle program. We don't have to carry the ops costs of that huge recovery system and refurbishment system that we had for the shuttle. And without a parachute recovery system on there, you get more mass to orbit. So maybe sustainable is not the best word. It's the one that fits within the budget that we have so that we can sustain it as we move forward into the future and get more money to evolve it. You're not paying this huge price to get to an end rocket. You're paying a price to get to a rocket that gets you an initial capability that you can evolve to what you eventually need with a smaller additional cost to make that happen. Another question. Yes, sir.
Hi, Chris Nye from the University of Colorado. I was wondering if you foresee any scheduling problems between government launches, military launches, and commercial launches all out of the Cape and Vandenberg, and if so, how do you intend to manage those?
Okay, that's a great question for the Air Force and the 45th Space Wing and the folks out at Vandenberg. First off, on commercial flights, well, a couple of things. The airspace over the Kennedy Space Center, there's an agreement called Webb-McNamara that NASA has given the Air Force responsibility for control, public safety, if you will, not control, but ensuring the public safety from NASA launches. If it's a commercial launch, the FAA is responsible for licensing that flight and ensuring public safety. So now, depending on where that commercial launch is from, I think as we move forward, we're going to have to take a look at who's responsible, how do we do this? Because I don't see any reason that if you have a commercial launch that's FAA sanctioned, that they are responsible for ensuring public safety, and it launches from the Cape. The Air Force can be launching one of their rockets and doing all the things that they do to ensure public safety. If the FAA takes responsibility, there's no reason a commercial launch couldn't launch an hour later. you don't have to turn the range around and support both of them with the 45th Space Wing assets. It all depends on how it's set up, who's doing what, and what agreements you have in place. So I think there's some work for us as we move forward to ensure that we have the most efficient, optimum way of coordinating our efforts, if you will. But right now, yes, launches from Kennedy Space Center and Cape Canaveral Air Force Station are controlled by the Air Force to ensure public safety. Anyone else? Yes, sir.
Good morning. I find the commercial crew program, I think it's a great use of funds, and I was just curious either where you think it will or it should go after the current phase is over.
Well, I think we should be funded at the level that the President asked for so that we can be successful to deliver something on time by 2016, 2017 timeframe. Again, given the budget constraints that we have and where we end up with, as we move forward, it's going to determine how quickly we can deliver on what we need to do. And if it's not funded at the proper level, obviously, it's not going to make the time frame that it's required. Things slip out. And the sad part about this is, as with any program, unfortunately, funding is always a constraint. But it's kind of like pay me now or pay me later. Oftentimes, if you fund it at a lower level and you slip the schedule out, it costs more money in the end than if you'd just funded it up front. But as we all deal with our home budgets, we don't always have the money to do what we want to do right away, but we got more coming down the road, and it's easier just to pay a little later rather than coming up with all the money up front. We'll see how it all works out. The key is, we have an opportunity as we move forward here to work together. I should say, right now, the NASA budget, what we're doing as far as commercial crew and our heavy lift program, we have a NASA Authorization Act, we have an appropriation. This is an agreement between the House, the Senate, the legislative side, and the executive branch of the government to go do this. It's been signed into law, and everybody agreed to it. So we got to make it happen. Now, hopefully, it will get funded at the appropriate level to do what everybody has agreed to make happen. There's a question over here.
Yeah, hi, Bob. Steve Brody from ISU. Good to see you again. When I was at NASA giving a few public speeches, the statistic I'd often used as well is we're at about 0.5% of the federal budget compared to what was during Apollo, 4.5%. And I'm wondering, I've been reflecting on that, in that at that time, in the Apollo age, much, if not all, of what NASA needed to do that program essentially had to be invented and had to be created by that infrastructure. Whereas where we are today, there's a lot of incredible technological capability and investment that surrounds the space program in all of our lives. So I'm wondering if your perspective might also be that with the 0.5%, we also are looking to leverage and not necessarily build everything ourselves, so to speak, but to leverage the investments that are being made in the electronics industry and the robotics industry for manufacturing, et cetera, so that the 0.5% is a measure, but to get a really good sense of the resources available to do the kind of things we want to do. It's more of a holistic approach of what our society can bring to bear to implement the missions that you're talking about.
It is, and part of what we're doing through Space Act agreements with the commercial crew program gets industry to put a little more skin in the game to get to where we need to go. You're going to hear from Ed Mango later during the conference here, but he'll tell you that he can show cost data that shows that the way we are proceeding with commercial crew is costing less than if we'd have gone out with a government procurement to buy that vehicle. So yes, that's true. The other thing about Apollo is, as they were developing all that stuff, because of the great push that we had to meet the President's guidance to do it by the end of the decade, they were doing things in parallel. They were working on multiple systems at the same time, allowing failure and then choosing the one that worked. We can't afford to do that anymore. but we have much better tools today than they had as far as computer design is concerned and how we work forward and develop our system. So absolutely, we should be able to do it more efficiently and cost effectively than it was done in the past, and we've learned a lot. But in the end, you know, it still requires a certain cost for the hardware, a certain cost for the people to make that happen and pull it all together. And when you're building hardware, space hardware especially, it's not cheap. And so it has to be funded properly in order to be able to do what it is we need to do. Right now, you know, we have funded a heavy lift rocket and a crew vehicle. But having a rocket and a crew vehicle doesn't get you anywhere. Okay? I mean, it gets you somewhere, but what are you going to do when you get there? There's still another piece that's missing. We either have to have a lander or some sort of crew vehicle that allows us to, you know, actually live and operate and do something if we go to the moon or the Mars or a Lagrange point or circle one of the moons of Mars, whatever. So there's still more design, and we're working on all this stuff, and we're working on an architecture as we move forward. You know, a lot doesn't get out in the public because it's not time to get it out in the public. We do studies. We work with, you know, the Office of Science and Technology for the President. We come together with a plan. You know, NASA is part of the executive branch of the government. We work for the President. And, you know, the President lays out his goals, and we have to meet his goals, okay? And we take that to the Congress and the House and the Senate, and things get modified a little bit. And in the end, we end up with a plan that everybody agrees to, and we push forward and make that happen. So I think we're doing all the right things. We just need to continue now to follow through and get them to completion. Got time for a couple more. Yes, sir. White shirt.
It's kind of an impossible scenario, but if you could have a dream budget, what would be your goals for NASA and Kennedy Space Center in the next 10 years?
Well, I've already laid out my goals, and we're making it happen. We're transforming Kennedy into a multi-user spaceport of the future. We're going to make science fiction reality. It's going to be like, you know, Flash Gordon and Buzz Lightyear and you name it. We're going to have suborbital flights, orbital flights, government and commercial. It's going to happen. You know, it may not happen at the speed with which we'd like it to happen, but this is the future. It is going to happen. Kennedy will become a true spaceport, where it's, you know, like going into Memphis International, where you got, you know, FedEx flying cargo, you got commercial carriers flying people, you got military flying in and out of there. Eventually, it's going to happen because that's our future, okay? It's like I tell my folks at KSC. You might not like where we are, and you might not like how we got here, but it doesn't make a hill of beans because we can't do anything about it. What we can do is define that point in the future where we want to be and set a course to get there, and that's what we've done. Would I like more funding to make that happen? Absolutely, but the reality of it is we've got a huge deficit in this country, and it's crippling us. And you can't have everything you want. So you got to make sure that you are the most efficient with what you get, and you are doing the right things with it, and you're not squandering or wasting those few precious dollars that we have. And I think we're investing in the right things to make the right things happen for the future. Yes, sir.
Okay, with, my name is Scott from Iowa State. With NASA's flat budget, what is KSC or NASA in general doing differently to ensure the United States dominates in space? And as a follow-up question, are you afraid of other countries closing the gaps?
Okay, first off, we are still the leader in space. Our international partners on the space station program look to us for leadership. They want to be part of our program as we explore when we go to Mars. They want it to be a joint effort. And the International Space Station model is an outstanding model for how we work together and move forward. You know, it's space exploration. First off, my personal belief, when we leave planet Earth, you know, we don't do it as the United States, we do it as people from planet Earth, and we need to do it together. And it's far too expensive for any one country, but it's critical to our future. So we will have international partnership as we move forward. The United States is still a world leader in space. We are still the best. We may not have our own vehicle right now to get our crews to the space station, But that's just a matter of national will. And our will right now is to have a commercial crew program that develops that vehicle and makes that happen. And we're doing that. I don't worry about competition. I know the NASA team. It is the most dedicated, talented workforce anywhere. When I was a pilot in the Marine Corps, I thought I worked with the best. When I was a test pilot at Pax River, it was a step above that. The folks there were phenomenal. When I came to NASA, it was another step above that. This contractor civil service team that we have, we know how to do it. They're motivated, they're dedicated, they're talented. Just as I said, point them in the right direction, give them the resources to get it done, and turn them loose, and we can do it. And we're doing the best we can with what we have. So we'll continue to move forward, and it's going to happen. And you guys, gosh, I can't imagine. I'm envious of all of you. You know, the future that you have in front of you, what you can be a part of, what you are going to make happen. I think it's phenomenal. It's going to be really cool, and I think you guys are going to enjoy it, being part of where this country's going in space. All right, my time's up. I think this is an awesome conference. I was looking at all the talks that you have and who you have coming to talk to you. I don't know how you pulled it off, but I think you got about every senior NASA official up here in Buffalo in November. And so my hat's off to Andrea and the University of Buffalo team that has pulled this conference together. You've actually done a tremendous job, and thank you for allowing me to come and be part of it and share with you what I see as our future. I really believe we have an outstanding future. I'm extremely positive about it. This last year at the Kennedy Space Center, we have made tremendous progress towards enacting that future and making it a reality. And I promise you we're going to continue to push ahead and make it happen. Thank you.